So, all right, well, let's get started. We've got two great presentations lined up tonight. A couple of guys that y'all might know a little bit, but they're going to bring some really good information to us tonight, and hope y'all kind of saw that in the email presentation on East Tex and what is East Tex, and also an antenna presentation done by both the gentlemen tonight, so that's going to be cool. Josh was unable to be with us tonight, and but he forwarded over where we are. I want to give y'all a finance report. And right now we have expended $3 on the last account, just $3. And that leaves our balance at $6,408.54. We got to get the 54 cents in there. And also the last update he gave me was 127 active members of TARC. So with that, I know a lot of y'all talk this club up, and you talk up the program and everything else, and we just want to say thank you from the officers and the board members at large, because you guys talk this thing up, because I hear stuff that so-and-so was talking about TARC the other day, and they're looking at it. So anyway, that's kind of where we are there. Joe, would you like to give us an update on the TARC loaner program, please?
Now, for those of you that don't know me, I'm Joe Lisbon, WB5SDV, and we've had this loaner radio program for several years now. And currently, we have loaned out 4 VHF, 3 HF, 4 all-mode, all-band radios for 11 total, and available to loan. Currently, I have 2 VHF, 1 HF, and 1 UHF, and 1 all-mode, all-band. And I just recently had in an ICOM 756 Pro, which I think is one of the better radios they ever made. It's it's 6 through 160, real good radio. That's available now. So and the only requirements are that you have to be a dues-paid club member with a proper license. You can fill out a application online, and it'll get to me, or you can just give me a call and come over, and we'll fill one out and get you hooked up with and you can pick a radio out. But we do have several radios available, so you just have to have the proper license and be a dues-paid club member, and we can get you on the air. I even have some coax and have some parts and pieces to make wire antennas, so there's no excuse not to get on the air. We can get you hooked up with something. So anybody have any questions? If not, and if you know anybody that needs equipment, they just have to be a club member in good standing. So, and just, I'm on the club roster, so if you need anything, antenna parts or anything like that, just give me a call, and we can probably take care of it. Thank you.
Thank you, Joe. We appreciate everything you do at the loaner program. It's a pretty good inventory sheet. It's front and back with a piece of paper. Joe gave me an update last month, and I was going to tell you, I saw on there's 2 Samlex 1235M power supplies that I saw on there from the sheet from last, if I'm still correct. I don't know if those are loaned out or not. I use those Samlex. If you want to try them out, that'd be it's a good little power supply to try it if you wanted to. I just sort of one's loaned out. And he still has one. So anyway, if you ever want to try out the Samlex 1235M, just give him a shout there, and he'll be glad to meet with you and connect you up with that. Butch, would you like to give us an update on the testing, where we are, and the good news that you shared with me this afternoon, please, sir?
Okay. Well, Sunday at the test session, we had 3 applicants come in. All 3 had no license when they came in. 2 left as generals, and 1 left with their technician. So everybody's successful in some upgrades. And we're back at the Red Cross now, even though for a while we were here at the church while they were remodeling, but we're at the Red Cross second Sunday of every month.
Thank you, Butch. We appreciate everything you and the team do to encourage those to upgrade and also to get their technician license there, so we really appreciate that. And it's always good to see new licensees in the hobby. And hey, congratulations. All right, there you go. All right. I have one of those too, so you and I, we're going to get along. We may not be able to understand each other over the air, but we'll work on it. But anyway, just teasing. But oh, yeah. Robert? and a youth got a radio. Andrew is excited about that, right? Woo-hoo. Okay, very good. All right. Well, thank you for that, Butch. We really appreciate everything that you do. Wayne, would you like to give us an update on where we are with the repeaters? Excuse me. That's plural.
The repeaters are working.
I was hoping he was going to do something like that because hey, do you mind giving a report down? Yeah, they're working. So anyway, it's cool because I will tell you, a lot of clubs are not just the lightning that we've had over the last year and a half, 2 years, or whatever we deal with, like everyone does, commercial and amateur radio both with towers. Anytime you stick anything up in the air, lightning's looking at it, we're going to catch it. But Wayne does a fantastic job, and there's a lot of others that help him, even when we had stuff to go down, power outages or whatever, running fuel back and forth, getting generators and getting things running and stuff like that. So, Wayne, we really appreciate everything that you do. Thank you. We're very fortunate to have folks in the organization that can maintain the equipment, unless y'all want to go simplex. But anyway, to maintain the equipment, I say that tongue-in-cheek, though. Yeah. But anyway, there's a lot to it to keep stuff up and running. It's not just plug in a radio like we do in our shack and turn her on and turn her off and let her go. So anyway, works out very good. So, Wayne, thank you, and those that help you do that as well. The other thing I had, a few things that are coming up. We have the Thanksgiving dinner coming up November the 21st. And Steve Plotner, W5SBP, is our captain, coordinator. Him and I couldn't decide on a term, so we'll, whatever, Lieutenant Colonel. Sir? No, we appreciate you. So we've also have sent out the sign-up sheet, if you will. I think it's called a Sign-Up Genius. You should have seen it in an email, and I think we also have it on our TARC Discord channel. You can go in there and sign up. And if you see some stuff that we need, if you will, we select a few things, kind of the common things you'd have for a Thanksgiving meal with an organization, with a group, or even a family, and click on those if you're interested. And I know the couple of years I've been here with the club, people will bring their favorite dish. And I just want to say and let you guys know, and y'all share with others, maybe you're not here tonight, if you have a favorite dish that you do for Thanksgiving, bring it. If it's not on the list and it's your favorite, bring it. Share something with the group. So anyway, feel free to do that. I've seen that happen a lot at Field Day, and also I've seen that happen here before. So feel free to do that. If you have any questions or concerns, you can reach out to Steve via email, and he'll be glad to. Sir? On the roster. He's on the roster. So reach out to him, and he'll be able to answer your questions, and feel free to sign up on the Sign Up Genius link that was already sent out. And Andrew, would you like to come up here and say a little bit about the upcoming emergency test?
Okay. Thanks, Gary. For those of you, hopefully everybody got the email from the News Blast a few days ago. Saturday morning, November 9th, we're going to start around 8:30 in the morning, and we are going to do an exercise, an emergency communications exercise where we are asking for volunteers who want to participate to go to a designated location and from that location check in. The scenario, which we're also going to announce on both ETEX and TARC repeater systems at 8:30 in the morning, the announcement is going to be that there's an ice storm scenario like we had a couple years ago. And the ice storm has taken out normal power and normal communications for our served agencies. That's our shelters, our fire, EMS, hospitals, etc. And so for this simulation, we're going to simulate that there's an ice storm, and we need operators to go to those designated areas and check in so that we can practice that aspect of communications. For those of you that have WinLink capabilities, we are also looking for a few WinLink operators to go out and send a WinLink message. We're gonna send out a pre-crafted 213 ICS 213 message for you to pretty much fill out with that information and send back, just for practice sending those WinLink messages. How it's going to go? Again, at 8:30, we're going to announce the simulation. At 9 o'clock, so Mark Taylor and I are going to be the net controllers, depending on which part of the simulation we're doing. Wayne, thank you, Wayne. Wayne was voluntold to be our backup net control in case something happens to one of us, as that can happen, right? So we're going to have 3 net controllers running the net. Going to have an announcement net at 8:30. At 9 o'clock, we're going to have a resource net. That's where we're asking who is out there, who is available, who can go mobile, who can go to whatever pre-selected geographical area we have. And then we are going to then, during that resource net, assign operators to go to that area. And our goal is to find an area that we need an operator that's close to where you already are. So if you live in Bullard, where's Robert? If you're Robert and you live in Bullard, I might say, okay, please go to the parking lot of the high school and set up. The scenario is that they opened the gymnasium for a shelter, which they actually did not too long ago. As far as going to the locations, we are asking that you just stay in the parking lot. We're not trying to go into buildings. There are going to be a few people operating out of buildings that are pre-selected. The Red Cross. I'm going to be at the Smith County Command Center, probably with another operator, and we're going to coordinate from there. So 9 o'clock is going to be the resource net. Who all's out there? Who all can check in? Who can go? And then at 10 o'clock, we're going to start the tactical net, and that's where we're actually now a little more formalized, asking operators to check in from that actual location that they went to, and or send a WinLink message if you have WinLink capabilities. At 11 o'clock, we are then going to connect the eText repeater system to the Freedom Link group. For those of you that don't know, the Freedom Link repeater system goes up through northeast Texas, even in a little bit into northwest Louisiana and southeast Arkansas. So we're going to be connecting to Freedom Link at 11 and even further expand the exercise. So that's kind of the rundown. We are looking for people, again, that can check in and say, yes, I can drive 4 or 5 blocks or 5 or 6 miles down the road to the American Red Cross or to a high school or to hopefully I have enough operators that I can send a couple to some of our volunteer fire departments. Some of our volunteer fire departments in ESD2 are actually backup command centers for the county. And so if something happens at the county command center, they will pack shop and go to, right now it's actually Flint Fire Department. So anyways, that's happening Saturday morning, November 9th. Announcement at 8:30. Start check-ins at 9. Mobilize from 9 to 10. And then the actual formal tactical net starts at 10. Off-grid power. Yeah, if you participate in the 10 o'clock tactical net, you do not need to participate in the 11 o'clock net where we connect with Freedom Link. We're really just looking to get check-ins from those operators for the multi-county area. So, but yeah, off-grid power. Again, the simulation is ice storm, has taken out all regular electricity, and so solar, battery, generator, mobile, your vehicle, whatever. Just don't plug into a. I figured most everybody would be operating out of their mobile radio in their car anyway. So, any questions? Mark your calendars. Please, if you're available to participate, please do. Let me know. Let John know if you are, and we will get you. I have a sign up now that I'm taking people that can tell me right now they're available. I'm starting to assign those people locations, and I will get with those people and tell them what they are, and then any extras we pick up that morning, we will also be assigning to some of our served agencies. So for those of you that are semi-new to the club, ETEX stands for East Texas Emergency Communication Systems. We are a separate club than TARC, but we work hand in hand, and most members of one group or members of the other, and so forth. But we are called upon by our served agencies when needed. We were actually activated in the spring when some of the really bad storms came through and took out all that power and some of their communications. So really, really important exercise. Hope you all can participate. Again, it's just seeing who we can get where and get a check-in. That way we know if an emergency were to happen, we at least have practiced doing this a little bit. So that's kind of the goal, is just practice makes it better. So anyways, that's it. My call, for those of you that are new, my call is N5EAB. My email address is on the email that the club sent, so just shoot me an email if you are willing and able to participate, and we'll get you going. So,
All right. Thank you, Andrew. Remember, if y'all have any questions, whatever, in the email and also on Discord, we have Andrew's email address on there. Reach out to him or see him tonight, too, and he'll go ahead and get you listed and get you an assignment and give you some additional information there. So if you are available during that time, check it out. If you've never done that before, check it out, and you'll learn a lot. It'll be a really good experience for you. Are there any questions for Andrew at this time? Just one more call. Nothing. No hands. Nothing. I see head shakes. Okay, sounds good. Well, what I'd like to do now is introduce Gene, a WB5CTQ. He's going to go through what is East Tex. And you'll hear a little more about the organization and what they do. And, Gene, you want to come up here, and then after that we'll go right into the antenna presentation with you and Wayne. Gene?
Thank you, sir. I guess my arrow keys will work, right?
What you have to do is this right here, sir. Yep.
That right there
Yes,
will
sir.
work. Okay, good. I am Gene Coldwell. I'm WB5CTQ. There are people in this room that are far more knowledgeable about ETEX than I am, but I volunteered. So that's why I'm up here. And this is going to be a 30,000-foot run-through. What is ETEX? ETEX is East Texas Emergency Communication Services. It is a 501c3 service organization. It's not really a radio club. The mission of ETEX is to provide communication services and capabilities to our served agency partners at times and places or where ordinary communication services are unavailable. That may be because there is a disaster or something that is like an ice storm that's taken out a bunch of stuff, but it may also be because the plane crashed in an area where there's no cell phone coverage, okay? And so one of us would go out there and provide a link back to other places. ETEX connects amateur radio organizations such as ARES, Amateur Radio Emergency Services, which is the ARRL emergency thing, Radio Amateur Civil Emergency Services, which is something that you all know that we are mostly doing state races here in Smith County. The Tyler Amateur Radio Club. When I came to Tyler, which was 15 years ago, there were 3 radio clubs that I knew about, and there were probably others in Smith County, but there was the TARC, the Tyler Junior College had a club, and there was the East Texas VHF FM Society, and they were all 3 different clubs. And so if you're at the Red Cross or you're at a served agency, how do you know who to call? That's what ETEX was designed to do. It was designed to be a brand. It was designed to be a contact point that linked the ham radio community with the served agencies. And we also provide connecting infrastructure and training. You heard the ETEX repeater system mentioned. Our served agencies, the American Red Cross, the National Weather Service, the Skywarn program is administered in this area through ETEX. The Smith County EOC, where Andrew's going to be. RAC-G, what is RAC? RAC is Regional Advisory Council. That is a thing that links hospital trauma response in an area. We're in the Piney Woods Regional Advisory Council, which is RAC-G. There's also a RAC-F that's also to the northeast of us. So we provide emergency backup communication for those guys. The East Texas Council of Governments, all kinds of things. We get strange off-the-wall requests all the time, but That's what we're here for. We're here to provide the point of contact. Our infrastructure, we have a linked repeater system. The repeater here in Arlington. I lived in Arlington for many years. I apologize. I'm sorry. The repeater here in Tyler is on the hospital. It is the 145.210 repeater, but it is linked to repeaters west of here and east of here and north of here and south of here. So if you're down in Athens and you need to talk back into Tyler, you do it through the E-Tech system. If you're out west of here, what's the 146.6? The Edom repeater, if you're out near Edom, you talk to us through, and the Edom repeater is a killer repeater. You can hear it in Corsicana. I'm not Corsicana, Texarkana. We also have a packet radio network. We do WinLink. John maintains a WinLink node at his house, so if you want to send a WinLink message somewhere, you do it through the E-Tech's packet system. We have radios at the hospitals, at the Smith County EOC. In some cases, those are owned by E-Techs. In some cases, they are owned by the served agency, but we helped them figure out what to buy, and we maintain them. And then we have a website at www.etex.org, which is where you can find all this stuff, okay? So that's why we exist, and that's why the simulated emergency test works through us. Now, why did I come up here and say all of this? Half of you already know this. It's old stuff to you. But we have a lot of new hams in our club now, and they are wondering, well, I'm interested in emergency communications. Where do I go? What do I do? Well, you contact E-Techs. We have a Monday night on net at 7 o'clock on the E-Techs repeater system on the last Monday of the month. And there's usually a training portion there. You can find information on the website about which FEMA courses to take, all that kind of stuff. So that's what E-Techs is. And we offer our training the last Monday of the month, training net. The Skywarn training, we work with the TARC to host the Skywarn training. There are FEMA ICS courses that you can take that are online. We do the RAC exercises. We only have one simulated emergency test a year, but we have 2 RAC exercises a year. All kinds of stuff like that. And occasionally we'll do WinLink workshops, that sort of thing. If you want to get involved, participate in the nets, attend Skywarn training, fill out a membership application at www.etex.org, and it'll go to John, and you'll get registered. Huh? No dues. We're not a club. We stand beside. Well, we are kind of a club, but we don't intend to be a club. We don't have meetings. We don't have dues. We don't have stuff like that. We intend to support emergency communications and link the club community to the served agencies. That's what we do. Okay. Now, yes, please.
Don't be scared to use the repeater system for regular amateur use. Don't be afraid to use the repeater system for normal amateur radio use. If it's not being used for an emergency, a lot of times the linked repeater system will go a while without being used, and we like to know that it works, because when we need it, we really, really need it to work, right? So don't be scared to use it when we're not running a net or such. That way, if there is a problem with one of the locations, we can identify it and correct it. So,
thank you very much, sir. Thank you. Okay, now I'm going to put on another hat real quickly. And Wayne's going to do the heavy lifting on this presentation. Again, there are people that I'm looking at that are more knowledgeable about these topics in this audience than I am. But some of you are new, and some of you need to think about some of these things once in a while again, and so here we are. I want to talk a little bit about antennas. Antennas are my love in engineering. I worked on antennas at NASA in 1969. I've just loved to play with antennas for a long time. So, and antennas are fun, and antennas are quirky, so that's why we want to talk about this. We used to have T-shirts in school that said this: those are Maxwell's equations. Maxwell's equations tell you how radio waves propagate through the air. They also tell you how radio waves propagate in coax cable. They also tell you how the energy gets from the generating plant down the transmission line to the place where you're using it, to your toaster or your television set. And if you don't believe that the power that goes from the generator to your toaster travels in the space around the transmission lines, we'll go down on Grande Boulevard there where that big transmission line is, and if you hold a fluorescent lamp tube up in the air right there, it'll light up because the energy is in the space surrounding the wires. It's not in the wires. So, coaxial cable that we use typically has a characteristic impedance of 50 ohms. The electromagnetic fields are constrained by the conductors. You got an outer conductor, you got an inner conductor. I brought a big piece of coax to shop night the other night. The electric and magnetic fields that transmit the power are between the two conductors. But the power that comes to your radio so you can hear stuff is coming through free space. It is not constrained. The characteristic impedance of free space is 377 ohms. 370, why 370? Well, that's 120 pi, don't you see? Well, you ask a silly question, you get a silly answer, you know. What can I say? The antenna is the thing that connects the 50 ohm constrained media to the unconstrained outside world. That's all an antenna is. That's all an antenna is. Antennas don't add to the power. Antennas may focus the power in some direction or another, but they can't. We talk about antenna gain, but that's really false. But antennas can be lossy. They can lose power. You can heat up the antenna or heat up its components instead of transmitting the power. Everybody wants three things out of an antenna. They want high efficiency. They don't want to lose any power in the antenna. You want wide bandwidth. You want to be able to tune your radio anywhere you want and not mess with the antenna, and you want it to do its thing just the way it does. And you want small size. But you can only get 2 out of 3. You can't, what Scotty said, you can't disobey the laws of physics. You can only get 2 out of 3 of those. You can't get all 3. So you pick which 2 you want, and you build your antenna accordingly. Antennas may have losses due to conductor resistance. Anybody know what skin effect is? What's skin effect? At radio frequencies, the current that flows along a wire flows only on the surface, doesn't penetrate very far. They call that skin depth. So a small conductor is not good anyhow, but if the penetration of the current isn't very high, it's even worse. Okay, so if your antenna is made out of wire that's too small, the skin effect losses we call that copper losses, they'll eat you up. You may have pieces of the antenna that are connected with pieces of plastic or other things like that hold it in shape, that are dielectric. But they can absorb energy too. Ice on the antenna is not all that conductive, but it can absorb energy. Okay, so that can contribute to losses in the antenna. What about gain? The only gain an antenna offers is directive gain. That is, it puts more of the signal there and less of the signal there. That's all an antenna can do with gain. You can't put 5 watts in and get a 100-watt signal out. You can sound like you had a 100-watt signal in a certain direction, but you can't get real gain. Gain's kind of a funny way to talk about it. Antenna directive gain is always measured in a direction, and the overall effective gain of the antenna is the loss multiplied by the directive gain. Or if you're doing it in decibels, it's the sum of them. So the loss is negative, the directive gain is positive. I want to show you how you get directive gain out of antennas here with a couple of pictures. Let's suppose Gosh, I wish I was pointing, but I can't, the way we're set up. The picture on the right, we're talking about 2 point source antennas there that are a half wavelength apart, and we're going to feed them in phase. Okay? Now, I'm sorry, I'm just going to have to walk over here and point. If I'm over here, I'm looking at both of those antennas, and the signals are in phase from both of those antennas when they come to me, and I see them adding up. It's fine, I've got lots of signal. But if I'm down here, the signal from the top antenna travels a half wavelength, so it's a half wavelength out of phase. It's a half cycle out of phase with the signal from the bottom antenna when it gets there. And when I look at them from a distance, they add to 0. They cancel each other in that direction. So I got good signal in this direction, no signal in that direction. Okay? What else fun things can I do? The other picture is 2 antennas that are spaced a quarter wavelength apart, fed in quarter phase. One way, they add up. The back way, they cancel out. And to the side, they have square root of 2 over 2 times the power. So, antenna gain is a function of pattern, and it's a function of the spacing of the pieces of the antenna and how you arrange them. Okay, and that explains, or should explain, why, my antenna SWR is great, but nobody can hear me. That's because everybody that you want to talk to is here or up there, and they're not in the pattern of your antenna. When the load is resistive, when we have this thing called complex impedance, and some of you know about it, and some of you, I'm going off the moon or something. But when the load is resistive, when it's like a resistor, that means the voltage and the current are in phase, and power is transferred to that resistor. It heats up the world. Everything is good. When those conditions are not met, some of the power is reflected, and you get what we call standing waves on the transmission line. We get peaks and valleys, and peaks and valleys. It's cancellation in places and reinforcement in others. So we like to tune for a minimum SWR. We like to set up the antenna for a minimum SWR, because standing wave ratio is what that means. Because that means we're getting a lot of good energy to the antenna. Except that doesn't tell the whole story. Because a dummy load has low SWR too, and it doesn't radiate a thing. So SWR is not the only way that you have to measure that antenna. You have to look at its radiation pattern and make sure that the power is being not absorbed in the antenna, but transmitted out into space where you want it to be. That's now, Wayne's going to explain this. Wayne actually computed this pattern. And Wayne, I'm going to let you explain what this figure means.
Thank you, Gene. Okay, so in this picture, the antenna is I have an 80-meter off-center fed dipole. So we have an 80-meter dipole. It doesn't matter where you put the feed point. We have 135 feet of wire going from left to right on this drawing along the major axis, or whatever you call it there. Okay. It's 135 feet of wire. The SWR is 1.07 to 1, give or take, on 10 meters at 28,360. Why can't I hear you? This is the pattern of the antenna as modeled by numerical equivalent calculation, or whatever that stands for. That's a complex pattern, and I can't hear you. Well, one interesting thing you notice, okay, we've got 4 major lobes, and they're probably, 30 degrees each way off the ends of the antenna. We think of a dipole as having a pattern directly broadside to the antenna, but that's not a dipole on 10 meters. It is an excessively long antenna with a complex pattern, you note that straight broadside on this antenna on 10 meters, there is no radiation. So if you, this is, by the way, modeled at, I think, 30 feet off the ground. And so why can't I hear you if that's what your antenna is? Because maybe I'm due north of you or due south of you. So patterns are interesting things, and they're something that you may want to consider because it's radiating great where maybe there is nobody. Continue? Okay. What's next? Hello, computer. Okay. True or false? Myth or reality? Let's go one by one. Pattern is absolutely everything to an antenna. Well, I would rephrase that slightly, but pattern is incredibly important in an antenna. True? Show of hands? False. You're correct. It is true. Well, basically. A simple single-wire antenna can be made to perform well on all bands. True? False? It is false. A dipole being labeled a basic antenna means that all other antennas are advanced. True? False. It is false. The optimal antenna element lengths are a function of wavelength, and shorter may be better than longer. True? False? It is true. Function of wavelength. Not feet, but wavelength. More expensive is always better. If an antenna costs more, it works better. True? True? And the key word is always. Keyword is always. False? That is false. I'll give an example. Chameleon makes some antennas and some antenna parts and kits. They have the price is higher than if you built it yourself. These are dipoles and variations on that. The engineering or the manufacturing quality and the material quality is excellent. But it doesn't perform any better or any worse than the same antenna design homebrewed or made by somebody else. So just because a $1,000 dipole is maybe you can spend that $1,000 a lot better. It'll work, probably, I hope. Anyhow, the more bands an antenna is to perform on, the less perfectly it will perform. True? False? It is true. SWR is the measure of antenna performance. I hope you can remember 5 minutes ago. It is a useful measurement, but it is not the performance metric. More peak gain is always better, and also gain is always gain. True? False? False it is. We have another page. More bands in the ad in QST magazine means the antenna is better. True? I think we figured that out. False. An all-band performant, simple, single-wire antenna is not physically possible. True? False? True. Simple, single-wire antenna that works well on all bands it may work okay, but does not work well. What about, a dipole is a basic antenna because it is the building block for improved designs. Is that true? False? That is true. What are these more improved designs? These are the Yagi, these are the log periodic, these are things like that. It's not, it's a component in a multi-element antenna. Boy, the placement of this is great. More metal or longer metal always makes an antenna better, regardless of what band it's on. True? False. You got it. I was reading, oh gosh, a month or two ago on the forums on QRZ.com, which I try not to read too often because it makes my brain hurt. But somebody said, hey, I'm putting up this 400-foot doublet for HF, and I'm wondering this or that or the other. And everybody asked him, well, why are you putting up a 400-foot doublet for like 10 meters or something like that? Well, I'm just doing it. And finally, after 2 pages of QRZ forums, the guy finally said, well, somebody told me that more metal, longer is always better. And so I can fit 400 feet, so why not do it? And he had heard that myth. Now, more metal is always better if it's too short. But lots of limitations. There are new antenna designs based on previously unknown principles of physics found frequently these days. True? False. Yes. The Maxwell equations have not changed in a few years. SWR tells you only how angry the transmitter will be, though it is useful to verify electrical integrity of the antenna system over time. True? False. That is true. The SWR tells you, it will tell you a couple of other things, but they're related to how angry the transmitter and the transmission line will be and how bad the line loss will be. But and it will tell you if an antenna is electrically the same as it used to be when you put it up. But that's about it. And finally, peak gain is useful only when you consider it in conjunction with the pattern. True? False. It is true. So, was there more after this? I can't remember. No. So, there you go. Antennas are fun. Is there? Oh, hi. Okay, do we have questions or comments? See, I've seen this before and I forgot. There might be a little bit of bias in that, but I tried. Go ahead, Andy. Right. Basically. Oh, yes. About more metal is always better, the question is, does that apply also to a receiving antenna, not just a transmitting antenna? And, yeah, I think so. A receiving antenna doesn't care a receiver doesn't care what impedance so much an antenna system presents the receiver. So it will hear fine with assuming it has the antenna has a pattern to hear somebody, unlike transmitting into the wrong band antenna. But the pattern works both ways, whether you want it to or not. Useless trivia, the G5RV antenna that was really popular as a starter antenna 20 years ago, still a good choice. It was not a multi-band antenna. It was a monoband antenna invented by, or developed, designed, built by Mr. Louis Varney, G5RV, for specifically its complex pattern. It has 6 lobes, 3 on the front, 3 on the... anyhow, because he had friends he wanted to talk to in 3 directions that were that far apart, and so he... the story goes he looked for an antenna pattern that would let him talk with his 3 buddies without having to turn anything. That's what he built. It has been turned into a starter multiband antenna. Anyhow, useless trivia. Any more questions or comments? Robert. Okay, don't beat you up too bad. I'll try not to. Okay. Okay. So what are contributing factors to an antenna having a broad bandwidth or a narrow bandwidth in terms of frequency? Generally, that means, things that will, a dipole is reasonably broadband in the sense that you can usually, on 40 meters and up, you can usually get the entire band within a 2-to-1 SWR bandwidth. 80 meters, you have to be pretty picky on where you cut it for. So a dipole is reasonably broad. When you start putting reactive components into it, like traps or loading coils, things to physically shorten the antenna, that increases the Q of the antenna, which means it narrows the bandwidth. And the extreme of that is the small magnetic loop antenna, the little 4-foot diameter things that have, when you put 10 watts into them, they have 1,000 or more, I think, volts across the feed point with a tuning capacitor there. They're incredibly short and small. And you're lucky if you get, 5 kilohertz? Right, more than one channel. So those are now you can also broadband an antenna by putting a resistor across it, because a resistor is 50 or is its value at any frequency just about. And so if you have losses, that may actually give you broader bandwidth if you have excessive losses. So those are some of the basics. Did I miss anything big there?
Like a hustler antenna,
Yep.
got the hustler coil, and then there's one coil smaller than the other one. There's a bigger one, and it is more broadband. Now, exactly in theory why, I don't know.
Mm-hmm. Yeah, the Hustler mobile antennas, which Butch has on his truck, I have one on my truck. They work good. Is a loaded vertical antenna. It's got a loading coil, and the comment was there are two different models of loading coil, basically, or whatever they call that. One is bigger, and the bigger one is a little expensiver, and it will handle more power, and it's also a little broader banded. And that is because, I believe, chiefly, the coil is made of a thicker wire. And so you have, that contributes to it being more broadbanded and having a higher power rating. Right, that lowers the Q. So the the small coil has smaller wire, and it is sharper. What else do we have? Yeah.
Anytime you have an antenna, anytime you have anything made out of metal, parts of it have capacitance and parts of it have inductance. And the inductance and capacitance give you resonances. You don't want, you want a resistive antenna. You don't want one that's inductive or capacitive if you can avoid it, because the resistive part is the radiation resistance, which is the coupling of the power into the free space. So anything that you can do to minimize the inter-element capacitance and inductance when you're building a loading coil on the top or something like that helps. That's why a bigger coil has less capacitance between the coil windings, and so it's less sharply resonant. Sharply resonant antennas, not too broad-banded, but when you have the antenna at resonance, and all the power is resistive, it's doing a good job. Assuming it's not lost, but it's assuming it's. Anyhow, there you go.
Thanks, Gene. You were better at that part than I am. By the way, I will throw in, I alluded to it, on this pattern here. This is the radiation pattern on 10 meters of any dipole, any simple single wire antenna that is 135 feet long. it does not matter where you put the feed point. The pattern will be this. So if that's an 80-meter dipole that you're using on 10 meters, the feed point's in the center. That's what the pattern is. Off-center fed dipole as a multi-band antenna, the feed impedance will change based on where you feed it. The pattern is the same. Move the feed point to the end. The end-fed half-wave antenna as a multi-band antenna, which is a terrible, terrible misnomer because it's a half-wave only on one frequency, which is the 135 feet. Anyhow, that is also the pattern on 10 meters. So I don't care if you're feeding it with ladder line or whatever. That's the pattern of 135, give or take, feet of wire on 10 meters, which is the same as if you had a 160-meter dipole and we're using it on 20 meters. It's a fourth harmonic pattern. And there are others as well. Anything else before I wrap? Yes. Right. If the wire's not, what happens if the wire isn't in a straight line, but it's an inverted V or something like that? Generally, it makes the pattern slightly less defined. It probably won't change the fundamental shape of the pattern, although you could put that into a modeling program and see what it does. Well, yeah, slightly a little bit less sharp. Now, the big thing is if you have tried to put the 80-meter antenna up and, your backyard doesn't fit it, well, yeah, you can bend it into a really complex shape. I've done this before. Across the house and down and then along the fence line, and then that fence runs into the back fence, and so you turn it that will really complicate the pattern. Yeah, and complicating the pattern that way usually doesn't make it work any better, I've discovered. Gary. Oh, yes. How high does an antenna need to be in order to avoid ground effect influence? Free space? Outer space? The height above the ground, we didn't put anything about this in there. The height of the antenna above the ground is a component in what determines what the elevation pattern is going to be. And so generally the higher, the antenna is within a handful of wavelengths of ground, say, within a few hundred feet of ground. The ground will act as think of it as a mirror, and there will be an image antenna below the ground. The elevation pattern is what happens when you phase those two, the real antenna and the image antenna, together at whatever spacing they are apart. And you remember the thing with the two antennas and and what the spacing does. That same principle goes into determining what the elevation pattern is and what angles it works at. Generally, lower angle means you're getting farther dx. So lower angle generally relates to the distance. Go ahead, Joe.
Yeah, sometimes if you have real dry soil or real wet soil, it makes a big difference. And you can tell when it rains, if you have dry soil, it gets wet, it changes. Mm-hmm. Sometimes for better, sometimes for worse.
When the ground gets wet, things will change because the conductivity of the soil is part of what determines how that works, and effectively that means part of that is how far is the reflecting surface, so to speak, at the ground, or how far below the ground is it before the soil is actually conductive. And depending on where, real-world example of this. My HF antennas are stupid low. They work better than they should, and I think it's because of the soil conductivity, and the conductive ground is actually a few feet below the surface. It seems to work. Andy?
So on what Joe said, in a prototype situation, you can buy like a grounding mat or things that you put on the ground to make it not the ground. What's going on there?
Okay, so POTA guys apparently have have some grounding mat stuff or other conductive stuff that you can put on the ground. I would think you would the place that would come in really handy, most useful. Okay, I can see two possible scenarios. You have a vertical antenna that you're using in this portable thing, and it needs a ground plane. And so you plop that under the vertical so that it has, at least right below the feed point, it has more metal under it so that image effect can happen where the image of a vertical is the other half of the dipole, of a vertical dipole. That's probably the best use case of that. I can see another one, although why would you? Well, if you have bad ground conductivity and you're trying to work really close in on, say, 40 meters, you're trying to get the angle very high, you might try to lower your antenna to 10 feet or so and maybe put a conductor across the ground beneath it. I'm not sure how effectively that would work, but that may be what somebody's going for. I hadn't heard of that in POTA before. But Gary. Well, first, anybody else? Because I think we're kind of yes.
I wanted to know what characteristics that makes a hex beam antenna work at 15 feet, as I always keep reading. And what is the benefits and the pros and cons of the antenna?
Okay, the hex beam antenna. How does it work? And how does it work so well? Yeah, right. So the hex beam is effectively a two-element multi-band Yagi. So you've got a driven element, and you got either a reflector or director, depending on the design. You could probably do it either way. And it's call it a tribander made out of wire that happens to be bent so that it is fairly compact and you can support it from spreaders and things like that. Why does that work? The higher where the current in the antenna is higher, which for a center-fed, center-fed half-wave antenna, that is around the feed point because the current is highest there. At the ends, you have voltage, probably, but you can't have any current because there's nowhere for the current to go. So, and radiation is performed or determined by where the current is. And I think in a hex beam, the middle bit of the element where the feed point is moderately straight, and they bend the ends around, although there's different designs. Gosh, how does it work so well? I think they experimented and got lucky. Is really the big one. Well, yes, and the elements are resonant. It's essentially a two-element Yagi on 3 bands or 5 bands or something like that. It's lightweight. The elements are small diameter. They're not 3/4 inch tubing, but they work. And again, it doesn't. The pattern is not impacted so much by bending stuff towards the end of an element, not nearly as much as it is if you do that at the middle. Just like if you put a loading coil on an antenna, it will have more of an effect shortening the antenna if it's close to the feed point, but it will also eat up all the current. And so you don't radiate as much. If you move that loading coil further out, you get more current going into radiation rather than heating up the coil. But then the coil doesn't have as much of a shortening effect on the antenna. Both of those things are kind of, at least conceptually, related. Joe?
I've had real good luck with some off-center fed dipoles. That one that works real well. I think maybe the first time I cut it, I just got lucky and said, whoa, I'm going to keep it that way.
Yeah, Joe has had very good luck with an off-center fed dipole from day one, or from cutting it, and that's great. I'll tell you that one of the challenges of the off-center fed dipole is the multi-band nature of it assumes that that the frequencies on the bands that you're using are harmonically related. So if you cut it for 3.5 megahertz, then 7.0 megahertz, that's the second harmonic. It is resonant. 21 megahertz, that's however many, but if you cut it for 3.6, or 3.8 phone band, and then you try to use it on 7.2, well, half of 7.2 is 3.6, and so it's too high on 40, and then things don't line up evenly. And half of the challenge with an off-center fed dipole is trying to get that harmonic relationship as close as you can so it's happy on the parts of the bands you want.
Yeah, mine works real good on 10, 15, and 20. Not so much on 40. I had to go to another antenna there, but it's had real good on those three bands.
And it's an 80-meter off-center fed dipole, 135 feet?
I think so, yeah.
I would expect that. So Joe has an 80-meter off-center fed dipole that works great on 80, 20, 15, and 10, not 40, and that's because of that harmonic relationship problem. I'm pretty certain. Anything? Yeah.
What about a double bazooka like our 40? It's supposed to be a little bit more broadband, isn't it?
Right. What about the double bazooka antenna on the lower bands? I have not used one. I'm actually not that terribly familiar with them.
I used one on 40. It worked real well.
Yeah. And the double bazooka uses coax, like RG8 size coax, as part of the element. That's a larger diameter, and that's probably a component of why that might be more broadband. Anything else? I feel like I'm going on long.
Yeah, I have a folded terminated dipole that works real good on 40 through 160, and I've used for those bands.
Okay, Joe has good luck with a terminated folded dipole, a B&W folded dipole on the lower bands. That antenna solves the resonance problem by putting a resistor across the element across from the feed point. That's how it gets to be broadband, and they work. The pattern is going to be complex, but they work. Anything else? Well, thanks. I've gone on long enough. Gene, anything else before we... Okay, Gary, it's all yours. And thanks for putting up with us.
Wayne, Gene, thank y'all so very much for presenting tonight. I just want to tell all of y'all, I know we probably could stay here for 2 or 3 more hours, but I would be in trouble, I know, and y'all would be in trouble, maybe. There are a lot of questions, I'm sure, but I will tell you, Wayne, Gene, and there's a handful of the members here. Some are in the room tonight, some are not here because of other schedules, that have a wealth of information, and I cannot stress how important it is to be a member of your local amateur radio club. And the reason for that, the number one, in my personal opinion, is the camaraderie and the fellowship, and the other is all the technical experience that you will find in your local amateur radio club. There was mention about different forums and stuff. I look at a lot of stuff, I read a lot of stuff, and I close it out and move on, just in my limited knowledge of amateur radio. But be careful what you do read and what you spend your money on. I don't know about y'all, but my budget is limited. And I'm sure everyone else in here is not experiencing the same thing, but my ham radio budget is limited, so I can't just throw money at stuff just because it sounds cool or someone wrote a really good article on it. Do a little investigation. TARC has a fantastic loaner program, especially for our newer amateur radio operators, or even you guys have been doing this stuff like I have for three decades now. Just borrow something and try it out, especially if you're fixing to spend the money for it. And try it out, because you're going to find out really quick, regardless what the articles say or the manufacturer says, and I did not say that, what the manufacturer says, and try it out yourself and see if you want to spend the money to own one of those. And you return that one to Joe. Well, you order your other radio first, and then when it comes in, you return it to Joe, and you're operating that radio that you found out that it's going to meet your needs in this fantastic hobby. So I just want to share that with y'all. I know we're running a little later than what I expected. I do want to thank Jay tonight for doing our audio video, and thank him very much for that. I talked to him, and he just jumped into gear, and then he could tell me how this was going to work, because I couldn't tell him. He had to tell me. But he was really good and very, very willing to accommodate so we could actually have this on the TARC YouTube channel. For those that were unable to make it tonight, I had several people reach out. I cannot make it tonight because I've got something going on and stuff. So it really does come in handy to actually broadcast or actually have this posted either live streaming or afterwards for on our YouTube channel. So if y'all check it out later if you want to. Don't forget, if you do have questions about the hobby, about Tyler Amateur Radio Club, you have any concerns, comments, or questions, reach out to any of us. I know we have. I know Josh, our Secretary of Treasurer, was unable to be here tonight. John, I didn't see him come in. I think he had a conflict. He's our Vice President. I do see Jack, our at-large board member here, and the little hand just raised up here in the back, our captain of the Thanksgiving meal next month, Mr. Plotner, Steve, is also one of our at-large board members. So we are here to serve you. We're here to answer your questions. And I will be the first one to tell you, I do not have all the answers, but I got some great resources to go to find those answers. And we'll try to find you an answer to your question. If one of us can't answer, we'll pass it around long enough to get an answer to get back to you. So don't go with any questions unanswered. That's one thing I do ask of our amateur radio club is, if you got a question, concern, or whatever, please voice that so we can address that and try to meet that request. So anyway, just want to share that with y'all. Before we adjourn, is there anything else that I have missed? Wayne, again, thank you. Gene, again, thank you. Y'all shared a lot of good experience tonight, a lot of stuff about East Texas as well. Remember to reach out to Andrew. Email him. Catch him tonight before he leaves. He's standing on the back wall. He's leaning up. He's not standing on it. He's leaning up against the back wall. Reach out to him. If you've never done any type of a disaster drill or tabletop or whatever, this is your opportunity because you will learn some really cool stuff. I've done this stuff for years with different operations in different states and whatnot, and done tabletops and evaluated tabletop drills. That's not a lot of fun because you got to do a checklist and just walk around and listen to people. But if you're actually involved and you find out how this stuff works, especially if you get to use your own radio, it's just really cool. You find out that stuff works during a drill as opposed to, hey, we got an emergency, we need you now, and you get out there and your equipment won't work or you don't know how to operate it. It's best to find out during this drill or during this exercise. Jack, sir.
We need to have people make suggestions for topics or to actually put on a presentation themselves for the club is for them and for everybody. We need suggestions on what you want.
Jack, thank you for bringing that up. I should have had that in my notes. We've actually added a deal in Discord for that. We want to hear from you on Discord, email, call, whatever you need to do. We want to hear what Jack was talking about. We want to hear from you on topic suggestions. What is important to you? We want to hear what that is. We've got the resources in the club to bring some really good information, true information on certain topics or on a lot of topics. So we want to hear from y'all to let us know what you would like to hear in upcoming monthly meetings and stuff. When I do have that information, I try to put that in the mass email to everyone because I've had a few requests. Well, Gary, before I come that night, I'd really like to know what's the presentation going to be. Well, I do too. And so we're all in this together. So we try to put that in our mass email to let everyone know. But we want to hear what topics are important to you, because if we just start pulling things out of the air, we might not ever hit what you're interested in. Jack, is there anything else you want to say about that? All right, thank you for the reminder on that. All right, one more call before we adjourn. It's awful quiet. Thank y'all again for being here. We really appreciate y'all. And again, if you need anything, just reach out to us, and we will try to accommodate you the best that we can, because we are here to serve y'all. So thank y'all very much. Be safe going home.